Just click the got it here. Okay. Well, we'll go ahead and get started. I want to thank everybody for coming online or in person. Great, thanks. Great to see you. Thank you. We are excited to have Mary Roldan with us today to share some work that she's been doing in her chemistry courses. And you can see by her title, Integrating Artificial Intelligence with Whole Student Learning, a cautionary in yellow, transformative framework for higher education. Mary has been using AI in her chemistry courses for about, is this her third semester? About 3 semesters now, so she's got some lessons to share, and we're excited to hear from her. So I'm going to turn it over to Mary, and we'll have time after her presentation for discussion with her, and then also some open discussion. So,
thank you, Sarah. I really appreciate it. So when I was tasked with making a presentation on AI and how I use it in the classroom, I said, well, there's a big caveat here, kind of like looking at, if you eat a snack and judging your whole entire meal or your entire nutritional portfolio based on that one little snack. And so I had to complicate things somewhat by talking about how I use AI and how I teach my class, because they're not separate. I don't just use AI. So I thought about it, and so I came up with this. It's more of a cautionary tale, because there are people who are really against AI and some people are really for AI, and I think there's a middle road there where you find a use in it, but within boundaries. It's not just free for all. Let's just use AI. So that's why I came up with this presentation. So again, we're looking at integrating artificial intelligence with whole student learning, and it hopefully opens up some doors and some questions maybe for people who have questions about using AI. So we all care about the education of our students. We all are basically curious about the new technology. We share those values of being concerned about the risks of using AI in the classroom and what this means for the community. And we have to ask the question, what is the purpose of true education, in order to look at how we can use AI effectively. So we're going to look at the history of tech just shortly, some AI applications and concerns. And in this presentation, we're going to look at some what I consider well-respected contributors to the field of learning and whole student development, which I think cannot be separated. And we also carry a warning. So here's your warning: proceed with caution. And I think our biggest fear with using AI is losing our humanity, basically losing the arts, music, and writing skills and thinking skills, and in general being put to work doing tasks that AI can never do, as you see in the picture. So let's start by looking at 2 polymaths who contributed to education that serves the whole student. And of course, we can think of many others. I think of Leonardo da Vinci, Goethe. They both contributed to both science, math, and art, and these were humans and they were not machines. So our first person that I wanted to look at here was John Ruskin. And the reason is that he was a polymath. That's a person with wide-ranging knowledge and learning. He was a writer, a lecturer, an art historian, an art critic, a draftsman, a philanthropist in the Victorian era. He wrote on a whole variety of different subjects, such as architecture, economy, education, geology, botany. um, he was very well-rounded. And one of the quotes that I found, which I have in my office, is the entire object of true education is to make people not merely do the right thing, but to enjoy them. Not merely industrious, but to love industry. Not merely learned, but to love knowledge. Not merely pure, but to love purity. And not merely just, but to hunger and thirst after justice. So we often ask, what is an educated person? And that's what I have looking at my desk every day, so that I can kind of remind myself that, this is just the beginning. And then there was, of course, Rudolf Steiner, who contributed a great deal to education. He was at the beginning of the 20th century. He founded an esoteric spiritual movement, and also the discipline of anthroposophy, which is the betterment of mankind. He had roots in German idealist philosophy and theosophy. He also started biodynamic farming, which takes organic farming to another whole level, much more pure, much deeper. And he was also the father of beekeeping and, of course, Waldorf education. A lot of the graduates from Waldorf education are leaders in their field. Um, and you can look into Waldorf education on your own. But one of the main quotes that I liked about what he said about educating people was a merely intellectual or materialistic educating works in a desiccating way upon the human being. In other words, it doesn't really feed the soul. And one of the things that he talks about, which might seem a little, esoteric to a lot of people, is the idea of an aromatic force or an aromatic influence, which is the position that the body is not animated by spirit and that we as humans are nothing more than a series of mechanistic movements that can be wholly controlled by the machine. So think about that for a second. I relate it to my children when they were little, and they weren't allowed to watch a whole lot of TV. They were allowed to play as much as they wanted outside, and they built things and they did a lot of things with their hands, and then they would come in, and if there was a movie playing or something, they'd watch the movie, and I'd ask them how they felt afterwards, and they were like, I just don't feel that great. And the more they spent in front of the screen, it was like, I don't really like it that much, even if they were drawn to it. And it's that drawn to that force that's called the aromatic force, being drawn to something that may not necessarily be that good for you. And I think it's a struggle that we all have today with, well, we know we're tired. We might just look at our phone. Oh, we're just going to scroll for 20 minutes. And like students do, that it ends up being 2 hours. And it's something that you have to really fight against. And I think that Steiner spoke to this. He said that the Ahrimanic forces were almost like chaos or destruction. He said these are sort of like the AI tools that give finished thinking. They basically replace inner effort. They create passive consumption. They separate knowledge from experience to replace thinking. And from an epistemological perspective alone, Steiner would have been quite disappointed with modern innovations. So, what activates thinking? We're going to look at that, but remember that our goal as faculty, we are not just teaching content. We are developing students who will succeed and want to learn. And that's something that's really important. As far as the history of the information technology, I think, is this moment really different from other advances? And is the impact going without any risk at all? So looking at the history, you could break it down in lots of different ways, but I looked at it as basically the blackboard, and the calculator. You could look at the blackboard, the one-room schoolhouse, which is now evolving to a bigger school with the advent of chalkboard. You can look at the calculator as another area of growth that caused people to think we would lose the ability to do math. In fact, Vonnegut wrote a story where all computations were done by computers, and it actually became a modern game to actually do the calculations without a calculator. So no one really knew where the calculations were coming from, in the book. And now in the past 25 years, we have the internet revolution with globally accessible internet, social media, and of course, AI. So the key questions that I'm looking at here, really, because what I do may not be what works best for you, but what is the best way to learn the discipline that you teach? And also, how can AI be used responsibly to develop students? And the key word there is responsibly. And how should AI not be used? Is it replacing thinking in your class? Are you using AI as a supplement? Or are you using it to replace your actual teaching? So what are the guardrails that prevent students from failing to think? Is this a time for a massive paradigm shift to move towards customization or integration with the community, or even individual choices that cater to the students' interests? So in chemistry, anyway, we all agree that students today want their formula sheet. They seek grades instead of learning, and they want solutions instead of to actually solve the problem, especially in chemistry where it's sequential. So it's really important that I see the work and not just the answer. And I think for the most part, students are bored, as a generalization with this new generation that's coming in. So the problems that we see in education, students have low persistence, they're not motivated. Many students are avoiding doing the math. They fight following the sequential learning that you need to do in chemistry. The students lack the conceptual transfer of knowledge. They say, here are some quotes, I studied, but I don't understand. I get so anxious, I forget everything during an in-class test. I've heard that, a million times. Most students pass the day passively video watching. They're answer hunting. They've got great grade anxiety, and they are socially isolated in constant existential crisis. Most of the students that I have that are having problems are having an emotional problem. They're not having an academic problem, or it's an emotional problem that's taking over the academic problem. So how can a student get an associate's degree and say that they cheated for 2 years? Or even worse, how can maybe not even worse, but just another example, a chemical engineer student of mine that I've heard say that no one ever gets through 5 years without cheating. So what's wrong with education and where's the learning? And again, we see here another problem is that there's high schools that are restricting technology, which actually might be a good thing in some cases. So I have this slide for the AI-driven fatal approach. So this is the thing that doesn't work. And I think people need to be aware of what doesn't work. Number one, the AI writes the paper and then the student simply submits it. Or the AI solves a problem or the student copies them. And this could have been also some of these tutoring uh, programs, apps that are on their computers. It's the same thing. They cut and paste and they just copy it. The AI summarizes the reading, but so the student never actually reads. Or in lab, the AI generates a lab report, but there's no observations of what happened. There's no insight, and it doesn't go a step further than that. So Steiner would have said that this weakens the will, that this weakens it to the point that they're not going to persist in that discipline, that the concept formation is also weakened, that their intellectual identity is weakened. And so this is going to create what he considered to be a susceptible, submissive follower, not a free person. And he was big into the idea of raising free children and people that could actually think. So I rate tread carefully in yellow. Can AI really strengthen learning? So the best way to learn is engaging with the material using a whole student approach. And these prompts can help a student who studies alone with only a tutor or with a class. So here are some of the things where it can strengthen learning. Number one is, instead of saying, give me the answer, replace it with, give me a similar problem, but don't solve it. So I tell the students, it's okay to use AI as long as you use it to help your learning. So the prompt, do not give me an answer, ask me questions until I solve it myself. So the student is getting, repetitive questions that could help him solve the problem. In chemistry, a possible prompt would be generate multiple incorrect structures so I can criticize them. So, I will admit GPT is not working really well for organic chemistry where they have to generate structures. I'd say 99.9% of the structures generated are incorrect, especially once they get very sophisticated. But that doesn't mean that it's not worth anything in organic. And I'll show you where I use it for organic. Number four is solve the incorrect problem. Don't do that straight, substitute with, check your sources. Oh, solve the incorrect problem means, okay, so the computer has done it wrong. I have A as a reactant, it's going to form B, but instead it's asking me about C and D, which has happened a lot of times. So solve the incorrect problem, see what's wrong, see what AI is doing wrong, and again, check your sources. If you're doing research, make sure that that's the right date, make sure it's the right, edition, the right pages, the right author, everything. And finally, share your findings with the class. That seems to strengthen AI considerably. So whole student learning, basically, I look at whole student learning as trying to hit from many different angles. So I have guided active learning assignments because in any discipline, students have to go through some sort of productive struggle in order to learn the material. And a lot of times the students today are suffering from some kind of disembodied learning. They just don't see learning as being very relevant. In some cases, even students who are majoring in biology don't see chemistry as being relevant. So that's why we have to have board work, we have modeling, we have labs, which improve the success of the students, which is why the student that is in person is asking for recommendations to a four-year school or internship programs or professional programs, but those that are learning exclusively online never do. In fact, you never even know their names because if you get a random email once in a while, that's about all you get from them. So as far as the whole student learning goes, we have the guided active learning assignments. You have lecture guides where the student has to solve the problems. There's dimensional reasoning. In other words, it's not about getting the answer, it's about showing your work. There's collaborative problem solving in the face-to-face classes. We now have proctored exams. And I have started using case studies to facilitate real world engagement. And I'll show you what I mean by that. So AI should not be used to replace reading, writing, or any sort of lab experience. As it says there, it is not the content delivery system, it is the practice engine. So if AI is used properly, it's going to give immediate personalized feedback, though it might be incorrect, which is okay, kind of like a tutor. It's going to remove the fear of failure, ideally increasing equitability. Well, I have a point about that later on. Number three, it allows unlimited practice problems leading to confidence. You can take a chapter from a book and you can say, give me the exam, 10 problems that have to do with this chapter. You could put your learning objectives into AI and say, generate problems that have to do with with these sort of problems. So you get massive amounts of practice problems through AI, though they might not be correct. It's kind of like your neighborhood tutor in some ways. But it does support independent learning, which ties to their interest. So the why, this is why I do what I do. So I have the lecture guides, which keep up, there's videos where the student has to write by hand. So you have that hand to brain philosophy where they have to write out each problem, which keeps me accountable. And that's important because the students say, well, this is on a test. Well, it's covered on page 59. So now you know that you should have looked at it. But who is actually accountable with AI? And that's just a question here. If it's wrong, who is the person that's accountable to it? Number two, the guided active learning assignments are going to encourage collaborative work. So you have this group work, and all of this is bringing life to thinking. And that's the idea of having these problem solving, um, basically reconnecting thinking with doing, which is going to hopefully build persistence. You have labs before theory, which is hopefully going to encourage questions. So what we're talking here is engagement, as much engagement as possible. And then the number four is delaying answer keys so students can correct their mistakes. So immediate solutions kill the struggle phase of the student. So you can have lots of things that basically are going to hurt the student, such as giving them a conversion factor. Here's your conversion factor. Now cancel out your units. That's not alive. Where if you took something like give an example of a real object that has multiple unit system conversions, then the student has to think about examples of that, building a bridge or rates of flow or something. They're going to have to think more creatively. So the strategy for AI integration starts, at the very start of the semester, of course, with the syllabus, which is teaching what's acceptable in AI use. And the second thing would be like teaching prompt literacy, which doesn't take a lot, but just having the students go into depth to avoid cutting corners, telling them you're not interested just in the answer, you want to see the process. Also, excuse me, require justification. So explain where the AI answers are right and wrong and have the students explain it. Why is this wrong? Why is this not something that we would do in that way? And finally, have a rubric for AI use with ethical guidelines written and of course the attributes. So the order of learning in science is basically to experience, interpret, draw some sort of concept, apply it, and then reflect. So really, AI for optimal learning should not be at the beginning of a lesson. It should not be the entire lesson, but it can enter in the middle or the end of a lesson. So what I look at is like replacement AI versus development AI. And this is an example basically of the concept formation case studies that I use and then the application. So replacement AI is basically saying write my emails, write my lectures, write my essays, or summarize this article, or solve this equation. And then the student just writes the answer. Whereas changing all your AI to developmental AI would be something like generate a misconception that I can analyze, or give me a harder practice problem, and or challenge my argument. All these are going to have the student thinking of what they're doing, and they're showing that they're thinking about it. They're critically thinking about what AI is generating. So this isn't just about preventing cheating per se. It's about building some sort of intellectual resilience to draw depth over speed, to retain the students and to prepare the students for a complex world and basically a four-year university or a workforce for that matter. So one of the requirements that I'm adding to my AI assignments is here's what I thought before using AI, and here's how my thinking has changed. So this way, if AI performs the thinking for the student, again, it weakens the intellectual foundation, but if AI is used to amplify student effort, then it's going to strengthen it. So how I apply AI is sometimes really simple secretarial work, like print me out 50 elements. And so the first day of class, I had printed out 50 elements. I cut them all up. I put them on note cards. And I said, have students find the students that have the elements of their family. So we have alkali metals, alkaline earth metals, transition metals, halogens, and noble gases. And, this worked really well when I had a double section. I had 47 students and we went to the workroom, where they can move around, and the students had to look up similar properties that are in their family, and they had to join the people of their family, of the element that they were holding. And the students reflected back and they were like, that was the most fun on a first day that we've ever had, because they were so used to just having syllabus read to them. And they were like, no, this was great. And there were 47 students, so there were a lot of people in the class. It took a full hour. The other things that I've done is with conversion problems, I'll ask for a one-step, two-step, and three-step conversion problem, and have AI generate that. And then I'll say, okay, what has AI done? Spot the incorrect answer, spot the incorrect, where it misread my prompt. And so the students can look at their own work and they can see what AI has done wrong, which I think that's a great way to do it. The other thing that I've done is with the lecture, I might cover something like periodic trends, where we're looking at electronegativity, ionization potential, atomic radii, and I'll break the students into groups, and then they'll do an AI search and they have to present it to the class with an example and the trend on the periodic table. So they might have only 10 minutes to look it up, but then they have to present it as a group. And again, here you have presentation, so you have more engagement. And finally, this semester I started using case studies. And the case studies that I'm using is from the National Center for Case Study Teaching and Science. And what I'll do is that it's written out. but they'll have to do an AI search and maybe even a literature search, and then they'll have to go on to the community to interview a pharmacist. Now, this is for an organic chemistry class where they were doing a case study comparing Nexium and Prilosec, which is, the second generation. They were reading about the development and activity of both and writing a paper arguing whether the Nexium is an improvement over the Prilosec or not. They had to examine pH, the significance of chiral drugs in stereochemistry, which is a big part of organic. And they were also introduced to the proton pump inhibitors in pharmacology. So they were basically doing the research and seeing what AI generated as far as the case study went. And then they had to go to their local pharmacy. Both of them work at pharmacies, so it worked out really well. And they had to ask the pharmacy about side effects, the pharmacist about side effects, and which drug was actually better. And interestingly, when I put this into AI, it said they were both exactly the same, but they weren't at all. And so, it's taking it to where the student now personalizes the information. And what I'd like to do with the case studies is present 5 different case studies that are very different. I do this in general chemistry now with an environmental chemistry one where they have to look at the water quality in the area that they live in, or that they vacation in, or that their uncle lives in. So they put in the zip code, of course, into some of the sites that are already exist, and then they run it through AI and find out what the water quality is. And what I'd like to do is have 5 different case studies where the student can actually choose to go into depth looking at that particular case study. So if they don't want to study, anti-cancer drugs, or they don't want to study the environment, then there are a lot of other options for case studies. And this, they're not cheap, but it's absolutely worth it if you teach science to look into these case studies from the National Center for Case Studies Teaching in Science.
So Mary, what was
So,
the result of the Prilosec? Or was you can't, there wasn't really. The,
oh,
the, huh?
there's a difference in the structure and there's a difference in the function of both because they're both very, very different. So the final thoughts here is no man chooses evil because it is evil. He only mistakes it for happiness, the good he seeks. And I think about that when they're trying to use the technology so badly. The technology can be used really, really well, but there's so many caveats to that because there's so much abuse. There's so much abuse in the technology, even with the, World Wide Web, with the internet, and with social media. Now we're adding a whole new thing. We all know about the problems with AI and this generation of students. So my analogy here is there's a new article in CNN News in January 26th where they have a pill for a healthy lifestyle. And the question would be, would you rather go outside and exercise, eat right, and sleep well, or would you rather take a pill that can mimic all 3 of these? So, you know, to me, relying excessively on AI is like taking a pill. It's complete with its unintended consequences, which is the reason that it must be used with caution. When people say things like, it's like building an airplane while it's flying, my initial reaction is, where's the parachute? It's not, oh yeah, let's see what happens to this airplane. And, so I do believe that there needs to be some caution here when you're actually looking at AI. So I did do the research here with different AI programs because my students are using different AI programs. They're not just using Chat GPT, which has biases and hallucinations, or Conmigo, which is basically like a tutor. There's Perplexity to give you research style answers with citations for lab. You have Elicit, which gives you literature searches, and SciSpace AI. There's also Claude Pro, which is best at understanding context from documentation explaining technical concepts. And then there's these programs that are just going down, they're just failing, like Find, which was great for literature searches. It made $10 million in a year, but then it had to delete all the personal data and close down less than 2 years after starting, and they just closed down January 26th. And of course, we hear about things like the Pentagon using Claude as best in class for military intelligence, which they used it, this weekend for strikes in Iran. So, I mean, you have lots of uses. Some are positive, some are negative. A lot of these different programs are closing because they want to privatize the information. They don't want everyone's data out there, and everybody's data is out there, as we all know. So unless you're completely, closed off in a cave, but it is something to think about. So I end this with a cautionary, warning. As I say, that's the end of my presentation. So thanks for joining, and we'll see what kind of questions